Okay, our next talk is titled Alioli ROV Submarine Drones. Giving this talk is Juanmi Taboada.
Good evening, everybody. Welcome to the venue. And I am Juanmi Taboada. I'm going to introduce you about how I built Alioli ROV submarine. First thing that we need to talk about is about the ROV. What is a ROV? A ROV is something, is a vehicle that we can drive under the water. It's nothing that we can get in. It's a vehicle that is independent, and we can see on our screen, on Google's, and we can see what's going on under the water. Everybody that you are here mostly are coming because of the open source, and the seed of what we do all is the passion. The passion for sharing, and the passion for producing software that we can share with everybody. We can get feedback from that. And it's a basic thing when you are evolving in this world. So this is what the main thing that brought me to make the submarine. I am a scuba diver. I am actually have the license for deep diving. It's 40 meters. And what moves me to make this project is the passion for water, is to be able to share what I like so much, what is going on under the water, to be able to share with people that I love, that I like, and my friends. There are people that can enter under the water, but there are some others that I cannot, because of conditions or whatever. So first thing that it happens when you get to the water first time is that you don't know nothing about the water. You have been swimming on the line of water, but you don't know what's going under. And it's a totally different thing. The first feeling when you start breathing under the water is like you can stand there, and it can start as long as you want to, but usually not longer than 45 minutes until 90, maybe 2 hours. So that was one thing that shocked me in the beginning, because it takes so long to prepare everything, to set the scenario so you can get to the water, equipment, the course, and the knowledge, just for 45 minutes or 90 minutes. So you have to make that time worth. So when you go to dive first time, if you need a license, and there are several licenses. The most common is PADI certification, and is the open water diver is the first license that you get, the first certification, and it gives you access to the first 18 meters. So that means that with a bottle, you can rent a bottle and get under the water until 18 meters. With being with your insurance, because if you do it by yourself, everything what happens, it will be on you. And then there are another certification is advanced diver, 30 meters, and finally the deep diver. After that, there is a technical diving. It's for professionals mostly. So how to break that limit of 45 minutes, 90 minutes, making your submarine? If you make your own one, you just can go avoiding all the preparation that you need. You just take your submarine, like you can take a drone that is flying. You plug it everything, plug it to the computer, put it in the water, and it's done. If something happens, it happens to the drone, not to you. You just pull it back and repair or whatever happens. So for that time, to make it worth, you better make a plan. It's like you are going somewhere, and what you see on the line of the water is just a reflection of the sky, and everything is blue on the top line. But under the water is like when you are on the mountain, and you can see rocks and hills and caves and things like that. So when you are going under the water, you have to know what you are going to see, because you can face the problem that you get disoriented. You lose the orientation very quick. You don't get used to. We learn to get orientation under the water, but in the first dives is normally, and especially when you dive in the first place. If I do it in the first place, I need somebody to instruct me about that place, how it's gonna be the geography under the water. Another thing that is makes important to have a plan because you had to predict your air. You have air in the bottle, and that has to last until you are out. Actually, we had to live always with a reserve. So to have that air, you had to make a good plan. If you are too deep, you are consuming that air very quick. So you had to be prepared for that. Maybe you are having too deep, and when you're coming back, you have to stop. You just cannot go out for the water, from the water. You have to stay in some until 5 meters, 3 meters, and you have to wait 2 minutes before leaving. It's just a very short distance, but the pressure, the difference of pressure is quite big. What do you see is what you get. When you are under the water, everything is blue. This is this is a photo of one of my scuba dives, and this is actually my wife. And what you see is blue. You see 15, 20 meters far. If the water is very clean, a little bit farther, but never like when you are outside the water. When you are in the hill, you see far, okay, we can go there and there is a river. No, but look that forest. Maybe we will try the forest, and you can see very far. And under the water, you don't have that. So you have to, somebody has to tell you about it. So sometimes it's just blue. Blue everything, blue. You are maybe at 15 meters, you have another 15 meters down, up, and you don't see any reference. So you have only your compass, and you have the depth of that dive in that moment. Another thing that I needed for building my own submarine is to have passion for computers and open source. This is actually a cluster based on OpenMosic, it was open source in 2001 when I was studying in the university, and that was actually one of my first projects to make a cluster, computational cluster, based on OpenMosic. One guy, one developer of OpenMosic is Malawian, so I could talk with him about it. That was it. That was what sparked my my knowledge about my needs of learning about open source and everything. Another thing that you need for making a submarine, passion for researching and learning. It's not enough to start building with the knowledge that you have. You will have to research, read, ask, get to forums, and sometimes you just have to keep pushing and working and thinking why this doesn't work. I remember especially one specific moment of the project that I almost made me to drop it because nobody could help me. So you have to be open for that researching and especially for learning. Definitely, passion for sharing. You don't make an open source submarine without this. That's a talk that I gave in 2003 in Malaga. I actually was president of Malaga Wireless when the wireless networks were starting in Spain. We wanted to share wireless internet everywhere. And probably I was one of the first guys that had a wireless network card in Malaga. And we started making these antennas and making these talks so we could share the knowledge with people. So this is what is going on now. What is the main concept of the project that I'm working on? My main idea is to build a 3D map of the underwater of all the areas near to the coast. I am not interested on deeper or farther from the coast. That's the reason. The reason is because it's for scuba divers. A scuba diver wants to dive in some place, it should be able to get a map with information, enough information and enough detail to know what's going on, where that person can go or dive, and what it will find. So my first approach was to take something that could scan structures, rocks, and hills. And that is, I thought, okay, so can be a sonar. And then I saw that the sonar needs a lot of energy and decided to go with fish finders. Fish finders are quite a good solution, but it gave me results like this. It's a cloud of points that then you have to merge, and you even don't have the texture of the sea. So it was very difficult to process, and I needed a big amount of electricity. So it didn't meet one of my approaches that was I wanted something that didn't consume much. So I was trying to work with microcontrollers only, no computers, and without putting electricity from outside, only working with batteries. So I met Measure. Measure is a framework that is a software for 3D reconstruction based on photos. You take photos of something, enough photos, and it will help you to rebuild the model, 3D model of the object that you are scanning or of making photos. So actually, that was a good idea for me because I didn't need much to make my project work because I just needed some camera recording the dive and my ROV doing the paths. So Measure, it was a great decision. Such a decision that based on these images that you can see, this is a video that I got from my friend Goiko Kremenik. He's CEO of Andalusi Robotic Submarines. And he gave me this video, and we decided to make a 3D model of it. And it came this. This is thanks to Measure. So you can see that it's a square shape. It makes easier to predict the proportions of the object that you are scanning. And there are holes and everything is not finished because of the video itself. The video, when he was diving, he was supposed to get into the pipe for scanning and watching what is going on there. But with the information that I had in the video, I could get to this. This is another video, also from him. And this is a pipe where residual water is being, after being processed, is pushed to the sea. So here we are scanning how is the pipe, if it's broken or if losing. For example, you can see that around on the sides there are algae. So based on the video and using Measure, I went to this. This is a reconstruction that I made myself. You can see here the algae on the sides as well. There is a little bit of texture. And I had to add myself a little bit of reconstruction to keep the proportions and the shape. But it gives an idea of how it works. Okay, let's talk about a little bit of theory. First thing that you need to know when you are underwater is the Archimedes law. The Archimedes law says that any object that is totally or partially immersed in a fluid is buoyed up by a force equal to the weight of the fluid that is displaced by that object. Okay, but what does it mean? Okay, imagine that we have this football ball and we are pushing it under the water. So when we push it under the water is going, of course, up and is flowing out. Let's imagine that we get all this water inside a recipient. We have it here. We get its weight. We measure it. So we know the weight of that water that went out. So that ball is being pushed up by the same force. What does mean? If you think if you push too deep, it will displace a lot of water. So the force from under will be too strong. So what happened with the ball is going up. So when the system is stable, when it's displacing exactly the same water than the mass of that object, then it's neutral. So this is it. It stays in a stable situation. No, this one is when the mass of the object is really small, but the force is being strong, so the object is pushed up. What if we make an iron ball? The mass is bigger than the water that can displace the same volume, so it will sink. It doesn't. The force is pushing up, but it's not enough. The mass will push it down. But there is another law. This is the law Boyle-Marriott, and it says that at constant temperature and low pressure, the volume of a gas mass is inversely proportional to its pressure. Again, what does it mean? We have a volume of 60 liters, and it's half an atmosphere. If we compress it to the half, we reduce the volume from 60 to 30. What happened with the pressure is double. So we move from half atmosphere to 1 atmosphere. What happens if we do the same again? We compress it and we divide the volume from 30 liters to 15 liters. We'll get the pressure to double again to 2 atmospheres. So let's see all of this together. If we put these two laws together, we have an object that we want to make into the water, and this is a submarine, and we want it to go down or up. So when it's on the top line of the water, on the beginning, it's not deep, there is the volume of the object is the size of the submarine, and there is a force that is pushing it up. So in some moments, we will measure, so the submarine will stay at the specific shape. Whatever is the object, it will make, so it will be stable. It will be displacing the same amount of water than the weight of it. What can happen is if we go deep, many meters, the object, the submarine itself, will compress. And if it compresses, it's displacing less water. When it displaces less water, there is the buoy force is smaller. So at some point, it was stable on the top line of the water, but we went down and it compressed, we lost the buoyancy. So it probably won't be able to come back. This is what happens in the Lego Submarine 2, version 2. When they made it, you see the surface, this is just a little bit, but enough to make the submarine not able to come back. So that was the first the problem that they have. Of course, the version resolved it, giving more consistency to the submarine, making the tap not to the cover not to blend. But still, if you move it to 5 meters, it will, because it shouldn't be that flexible. There is another approach on Lego Submarine version 4, which is using the syringe, is putting water in and out of the submarine. The idea is very good because it works very good in the first meters of the water. But if you go quite deep, the engine of that syringe won't be able to move the water out. Just will stay in, and the submarine won't be able to come back either. So this is something that you have to be prepared when you are taking a submarine many meters down. I'm talking maybe, if you go to 4,000 meters, they can compress, even the structure. This is what you see. It works, but it works on the line of water in the very beginning. I'm trying to make a submarine that is going to dive in the first 20 meters, maybe. Why the first 20 meters? Because the light of the sun, it doesn't get too deep. So most of the lives that is happening next to the coast, most of the interesting things when you are diving are happening in the first 20 meters. Usually after 20, 30 meters, you find just sand. So all of this together, again, it brings us to this image. If you look, there's a lot of information, but if you look at the depth and the relative volume, you will see that in the first 10 meters, you compress the air to the double. You get the double pressure, and your volume gets to the half. So you pass from one volume to the half of it in the first just 10 meters. In the next 20 meters, you do it by the third. So the most important compression that is happening here is happening in the first 20 meters. This is actually our point. I want to make a submarine that is going to dive there. So I had to take this in account quite strong. So with this, we are all set. And this is what I was trying to make. A fully digital control and telemetry, a submarine that can control and get telemetry from it in the digital way. I didn't want anything analogic. The two submarines that you saw before, they are analogics. They have radio control and they are sending signals through the remote control. And I have this submarine that I was making. It was a ROV that is under the water, and you see a buoy that is on the top line of the water, and it's using GPRS to communicate with the boat or the sea. wherever is the computer, and it's using the GPRS network. This is valid approach because my submarine will work next to the coast, and next to the coast there are a GPS connection. Through the GPS, I can get the 3D, the GPS signal, so I know where the submarine is, counting that there is a deviation from the cable. What else? I wanted to make it with microcontrollers. I wanted to learn from it, and I wanted to make the submarine to last as long as possible. So I didn't want to use computers, no Raspberry Pi, not small computers. Just I didn't want to deal with heat either. So I based the submarine. I based it in microcontrollers. Also, I wanted the wireless communication. That's the reason that is a buoy. I wanted the full structure to be able to dive through the water far away. This is one of the things that we have when I'm going for a mission with a professional submarine. This is one of the problems that we have. You have a cable from the boat, and the cable is going. And the cable maybe has 300 meters, so it's going quite far. But when there is a current of water, it's pushing the cable to the side. So you don't know exactly where the submarine is because it's bending. The cable is getting a shape. So in this way, everything moves together. What else? Wireless control and wireless video. So I managed to get both. I wanted to make a submarine that more people could build. So I wanted to, I was looking for something that could share with all of you, for example, and you will be able to build it with the tools and things that you have at home or at your hand, at least. So I started using PVC pipes. They're easy, they're cheap, and you have to be able to cut them. Also, I decided to go with low-cost hardware. My first Arduino kit. I knew electricity because of the university, but I didn't have a deep knowledge. I never had the chance to practice with it. So I bought my Arduino kit and I said, okay, this is done. It's gonna be so easy. There are so many experiments. It has to be quite simple to make a submarine with this. And it takes a little bit longer. I started making my own boards. The one on the left is my first versions. I thought that the cable under, for example, were easier because I didn't have to mess with it, but it wasn't able. I wasn't able to put it somehow inside any box or anything. That was very complicated. So I started making what you see on the right. That is a different approach of the board where I'm soldering on the top. Of course, the next step of this is to print it properly in a circuit. I went first time with Arduino Mega. I thought that would be enough, and it was enough. The submarine itself has inside an Arduino Mega, and it's managing everything. And for the buoy, I started with Arduino Mega, but I started having problems also with the memory. So I moved to ISP32. I said, okay, that's going to be a great choice. And again, I had problems with memory. I had problems with the stack and the RAM. They were mismatching one with the other and giving me problems. So Raspberry Pi Pico, it gave me all the solutions. So the buoy has a Raspberry Pi Pico on the top line. So we have Arduino Mega under and Raspberry Pi Pico. Why I had RAM problems? Because I needed to put into the buoy, I needed to put a library named Mavlink. It's a communication protocol that used to talk with the submarine. The problem that I was having with it is that even if I reduce the number of commands that I was using and the commands that was accepting the submarine, still wasn't enough. So I moved the reception of the commands from Arduino Mega that was under the ROV, because for me, buoy was a gateway, and I had to move it to the top line. So all the logic now is happening in the top line. The Mavlink protocol is being processed on the top line of the water in the buoy, and the buoy is sending very simple commands in binary format to the submarine, and the submarine is responding on that way also. Okay, software requires a debugger and hardware too. This is what you see on the screen is OpenHandTech. This made my days. It resolved many of my problems during the development of the board. For example, I had a GCM GPRS module, and when I was plugging it to the power supply to the home, it was starting and working perfect. But when I was using batteries, like drone batteries, that they can give a lot of energy just in a second, they was shutting down. It was sucking all this electricity from the circuit. Even if I use diode, I was using capacitors, it wasn't enough. Then somebody came and told me to look at supercapacitors, and I started using them. I knew because I was using the oscilloscope. It was giving me the information, enough information, so I would see that spike and what's going on in the circuit. And I knew that my Arduino was shutting down, actually, because there is a limit of 3.3 volts. But then Open Hunting wasn't enough, and I met PulseView. PulseView is just one of the best softwares that I have been. Both are open source, but PulseView is a great software for analyzing data with the oscilloscope, because you plug the sensor, you see the lines there happening, but you can say to the PulseView, you can say, okay, this is an E2C protocol, and CLC line is this sensor, and CLA is the other sensor. And he's decomposing, is decoding the protocol itself. So this one helped me to find out some noise in one line that was producing one component with another, which helped me to resolve. That was actually with telemetry. It was working most of the time, but in specific condition, it wasn't. What can bring a digital submarine has a lot of data, because everything is digital. So I am an engineer. I can dump all this information back to the cloud, and then I can process it, save it, and do stuff with it, get the graphs. So I have this, but it's giving me temperature of seawater, of the batteries, of the engines, the amperage, the voltage, because that helps me to know how much electricity I do have in each batteries on the buoy and on the ROV, and definitely the depth and everything. This is an extra thing. I didn't need this, but I had it. Why not? Why I use Mablink on the top line of the water on the buoy? Why push myself to use Mablink? Because I met ground control. Thanks to this friend that gave me the possibility to pilot, to control the submarine, a professional one. I saw that he's using this software, and the software is free, so it's open source as well. So I went through the protocol of Mablink. Mablink was providing telemetry, and it was reading the communication, the controls, the commands. So I could say to the submarine what to do using Mablink, and the submarine was answering with Mablink with the telemetry. And what about the video? The video, I was using this module. I was thinking, okay, there are drones, thousands of drones on the world, and they are using, they are driving drones far away, 1 kilometer. What is the technology behind? So it's 5.8 gigahertz. So I made these chips, ETA's 835, and I put that in the buoy. So with the SkyDroid, that is the small component, I plug it to my phone or to my computer. So I have like a camera that you have at home. I have the image that is producing the drone, the submarine. So what was the big thing there? That I was building a system that is supposed to be aware of the noise of the lines. And that was one way of thinking, because under the water, one of the problems is to get the signal under the water wirelessly. So on the cable, there is no noise. So I put the video signal from the drone camera, which is on Alioli. There is a drone camera from the air. I put it under the water, and I'm putting this signal back to this chip, and it's being sent wirelessly to the device, to my computer or the wireless or the Google's through the phone, or both at the same time. This is a micro minim OSD. This is under the water. This is inside the ROV. And it's a chip that is giving the OSD information. Why? If I had the telemetry, I had the data logger, and I had the ground control showing me the telemetry, why I decided to add an OSD also? Because I didn't want to deal with the lag of the network. I wanted to have fresh images, and I am the one who is driving. I need to know what's going on in the submarine just on the right moment. So the submarines that have the cable, they are very reactive. You just move the submarine and you see the reaction on the program. But thanks to I was using GPRS and all the protocol and the microcontrollers themselves, it was being a little bit, there was some delay. So I decided to avoid it, introducing an OSD board, this one, that you can make you can program it, and you can decide, okay, here will be the voltage and the battery and things like that. When it's nice on this board is that it's working with Mavlink as well. So I killed 2 DACs with one shot because I resolved with QGround the telemetry, but also mini OSD was reading the same protocol. So this was almost straight. And what else? One thing that I get from this project after making it, and I will do it in the next versions, is the divide and conquer. I miss it when I was building the ROV. I wanted to make it with Arduino in the beginning and later with the Raspberry Pi Pico. But Mavlink is a protocol that works like in a car. It's working in units. So it was easier to have a little module for the engines, little module for the telemetry, and all of them sharing the bus. So I could be able to handle each of them using just the same bus, and it will be easier. I wouldn't have so many problems with RAM. So next version will be it. Another thing that I was working on was the water analytics board. It's what you have on your screen. This is built, actually, this is real. And it can analyze pH of the water. It can analyze redox, oxygen in the water, conductivity, salinity, and several other things. So this is something I have to add to my ROV to be able to make the water analysis. And there is also a torpedo. This is a different project based on the same things. And it's an approach like Fast and Furious. It's a submarine, which shapes like a kind of torpedo, and it's made with ISP32, a MicroPython. And the point is to give a plan, and using the GPS is supposed to make a path on the water. So when I plug the water analytics board, it can't give me information about the big amount of the big area on the sea. And this is it. Also, I was researching about the propulsion system. Since the Alioli ROV is working with propellers, this one is working with impulsion system, like a water motor that is pushing water outside, like maybe like a rocket. And what else? Other usages that we can do we can give to the ROV? Underwater photography. We can use it for body searching. We can study and add on invasive species. Actually, we have done with professional submarines. There are some algae that they are where they shouldn't, so we can act on them. Especially, like I said in the beginning, disabled people with underwater health condition and diseases. I have a friend especially that cannot go under the water, and he would love to. So I can share that, my experience, I can share it with my friend. Definitely game simulations, racing, wars, and competitions. All of that is open. And finally, cheap bathymetry. Bathymetry is the science of measuring the depth of a place. So there are maps of it. This is a very cheap way of making it. But we are engineers, and it's not never enough. When this year, in spring, I was able to get my hands on the professional submarine. And I was able to open it. And with the knowledge that I got during the development of Alioli ROV, I was able to discover the several components that they had. This is ArduSub. It's based on ArduPilot. And I knew it before, and it is working with P-Hawk. It's actually a great board. I decided not to use it in the very beginning because it was expensive, and it is expensive, in my opinion. But so I decided to go with Arduino because of the price, because I wanted to bring something that everybody could make in any part of the world. 160, 170 euros is maybe a big price in some parts. So, but still, what I learned from here is that with just a Raspberry Pi and P-Hawk, you can have a submarine. Of course, it's not that simple. You need many components, but you have many of the drones that you are using drone on the air. They work already with it. So why not? And this is Alioli. That is so.
Una más de este. Otro. Y ahora los dos. Genial.
So this is it. Some questions? I think that they're giving, yeah.
So are you planning to add the light because in most of world the water is not so not so much light, and have you done it maybe already?
It will be some lights. Actually, the submarine has, this submarine, Alioli, has two batteries. Has one drone battery inside and one external of 12 volts, like I don't know how to call it. This bike, electrical bikes. So they have a little big one. So there are two batteries, and this one is providing the energy for the engines, the propellers, and for the lights.
Okay, and I will suggest you try to take the underwater flashlights from diving.
Yeah, it could be a solution, like recording put it the camera. It's the same solution. It actually is the best approach.
So I might have missed it, but what's the final price of this submarine?
That's
How
a
much
good
it costs?
question. Are we counting the hours they spent, or because it depends? The average price is around 1,000 euros. It's not that cheap after all.
But what's the range of the price? Like,
Sorry,
what's the approximate price?
1,000 euros, more or less.
Do you have problems with cheap components and pressure?
That's a good question. No, because actually the components that I'm using for under the water, in the very beginning, I was using a small board that is supposed to work with 14 atmosphere, but it was a board. So what I saw is that they are putting some silicon on it and everything. Silicon is protecting and it's not measuring fine. Then I got to the idea of thinking about where are other places that has a pressure sensor and works in the not so nice conditions. And I got to the engines of the car. The engines of the car, inside the engine, there are a pressure sensor for the oil. So they work in the very strong conditions. So this is what the submarine has. Some more questions? So thank you very much.